$50 billion. 3.2 gigawatts of raw nuclear power. One singular structure. The United Kingdom is running out of time. The national power grid is bleeding out. Old nuclear reactors are dying, decommissioned, shutting down one by one. Darkness looms, rolling blackouts, sub-zero winter temperatures, total industrial collapse. This is not a standard construction site. This is a desperate national survival mission. Welcome to Hinkley Point C, the ultimate nuclear fortress, the most complex megaproject on Earth. 25,000 workers, 3 million tons of concrete, forged in impenetrable steel, built to withstand a 10,000-year earthquake, direct commercial airliner crashes, the relentless, crushing fury of the Atlantic Ocean. Failure is not a statistical option. If this facility fails, the nation goes dark. How do you construct an engineering fortress this massive? You fight the earth. You violently force the sea backward. You bleed for every single millimeter of progress. The countdown clock is ticking. The sheer physical scale is impossible. The stakes are absolute. The location: Somerset Coast, the Bristol Channel, a geographical nightmare. The enemy is nature. The second highest tidal range on the planet, 15 meters of violent water displacement, twice a day. 40 million tons of salt water smashing against the shore, ripping at the bedrock. You stand on the crumbling edge. The wind howls at 120 kilometers per hour. The freezing salt spray stings your eyes. Beneath your heavy boots, the ground is treacherous, a geological disaster. Interlayered limestone, fractured, brittle mudstone, highly unstable, structurally weak. A catastrophic foundation for a hyper-dense nuclear reactor. A massive 14-meter-deep terrestrial excavation. 4 million cubic meters of dense earth. Ripped out by heavy excavators, transported away. The sea wants to drown this land. A massive 13.5-meter-high seawall, 900 meters long, built immediately. A brutal concrete shield against the raging Atlantic, defending the deep crater.
I look down into the massive pit, 30 meters below sea level.
It is a chaotic war zone of burning diesel and thick mud. The deafening roar of heavy machinery echoes off the jagged rock walls. 175 kilometers of subterranean cabling, 76 kilometers of steel piping, buried alive in the trench. The water table constantly threatens to flood the entire site. 100 heavy industrial pumps running 24 hours a day are extracting 2,000 liters of muddy groundwater every single second. The earth fights back constantly. Geologists map every microscopic fault line, every tiny crack. A $50 billion financial gamble resting on shattered rock. The ground must be violently stabilized. 110,000 high-tensile steel soil nails driven deep into the cliff face, securing the outer perimeter. The massive arena is set. The violent sea is held at bay. The earth is pinned down. Now, the real engineering begins. The nuclear foundation must be poured. A foundation unlike any other in human history. The base mat, the nuclear island, a logistical nightmare. 9,000 cubic meters of nuclear-grade concrete. A continuous 72-hour operation. 50 degrees Celsius, curing heat radiating from the ground. The sharp smell of chemical hardeners mixing with sea salt. 5,000 tons of dense interwoven steel rebar. 4,000 workers rotating in brutal 12-hour shifts. No stops, no delays. A cold joint in the concrete means critical structural failure. A monolithic slab. The logistics are military grade. 250 concrete mixer trucks arriving in a synchronized loop. GPS tracking on every vehicle. A traffic jam means drying concrete. Drying concrete means failure. The laser levels scan the surface continuously. 0.5 millimeters of tolerance. The sheer physical exhaustion is visible. Men covered in gray slurry, eyes bloodshot, adrenaline pushing them through the night, pushing massive vibration hoses deep into the wet mixture, eliminating microscopic air pockets, creating absolute structural density. The future reactor core foundation is locked in. Look up, 250 meters high. The sky vanishes. Saren's SGC 250. Big Carl, the absolute apex of heavy lifting, the largest land-based crane on Earth. 5,000 tons of raw lifting capacity, 12 powerful bogies rolling on 6 kilometers of dual steel rails. The massive yellow boom swings. 1,000-ton prefabricated steel reactor containment rings. Suspended 40 meters in midair, an ultra-wide shadow drops across the massive gray concrete crater. The brutal coastal wind batters the suspended steel. Tension cables scream, precision maneuvering. Down below, micro scale.
I watch a lone engineer, mud-soaked gloves, heavy rain hammering his hard hat.
Gripping a 5-kilogram pneumatic torque wrench, 1,500 Newton-meters of force applied, violently locking a single high-tension steel bolt. Sparks fly, millimeters matter. The extreme macro colliding with the critical micro, forging a megaproject. The containment walls rise. The nuclear fortress demands immense cooling. 3.3 kilometers out into the violent Bristol Channel, 33 meters below the dark seabed. 3 colossal tunnel boring machines. TBMs, 1,200 tons of grinding steel. 7-meter wide tungsten carbide cutter heads, tearing violently through solid limestone. 20 millimeters of brutal progress per minute. 150,000 massive concrete wedge segments locking into place. Hydraulic rams pushing with 10,000 kilonewtons of force. The rock shatters. The conveyor belts bleed endless excavated mud. The underground tunnels form the vital lungs of the facility, designed to pull 120,000 liters of freezing seawater every single second, cooling the 3.2 gigawatt nuclear reaction. The mechanical grinding is rhythmic, deafening, relentless. Then, the rhythm dies. Alarms pierce the suffocating tunnel. Red warning lights bathe the damp concrete walls. 3.3 kilometers offshore, 33 meters deep. A hidden geological anomaly, an unmapped fault line. High-pressure seawater violently forces its way through the fractured rock. 3.5 bar of atmospheric pressure crushing the exposed cutter head. Silt, abrasive mud, freezing water flooding the forward extraction chamber. The massive TBM jams abruptly. The tungsten teeth lock against an impenetrable rock shelf. The steel frame groans under the immense geological load. Progress halts instantly. A catastrophic engineering failure looms. The tunnel structure threatens to buckle. The freezing Atlantic threatens to drown the $50 million machine. You are trapped inside a claustrophobic 7-meter steel tube. The ambient temperature spikes to 45 degrees Celsius. The air is thick, unbreathable. The acrid smell of burning hydraulic fluid fills your lungs. Automation is useless. Human intervention is demanded. The crisis protocol initiates. Extreme hyperbaric diving teams deploy. Specialized engineers seal the pressure airlock, pumping in dense mixed gas helium, pressurizing the human body for hours, matching the deadly weight of the ocean above. A claustrophobic nightmare begins. Crawling into the flooded, pressurized cutterhead chamber. Pitch black. The blinding white sparks of heavy tungsten arc welding briefly illuminate the muddy void. Yellow hazard suits covered in dark gray sludge. 50 continuous hours of manual excavation, ripping jagged rocks from the jammed metal teeth by hand. replacing shattered 100-kilogram steel cutters in the dark. The divers rotate. 45-minute limits. Nitrogen narcosis is a lethal threat. The mud is toxic. Vision is zero, relying entirely on touch. Feeling the jagged rock. Feeling the razor-sharp, damaged tungsten teeth. Hands bleeding inside pressurized, thick rubber gloves. Inch by agonizing inch. The obstruction is cleared. One slip, a ruptured suit. The pressure crushes you instantly. The sea swallows you whole. The mammoth machine restarts. A massive vibration shakes the seabed. The cutter head spins. The ticking clock screams in your ear. The $50 billion fortress hangs on a single frozen steel blade. Deep beneath the crushing ocean floor, the TBM breaches the seafloor. The final breakthrough. 3.3 kilometers from the coast. A violent eruption of compressed rock. The steel beast surfaces. Extraction begins. Brutal reality sets in. 1,200 tons of dead machinery must be disassembled. Lifted from the churning Atlantic. Heavy marine vessels fight 90-kilometer-per-hour winds. 10-meter rogue waves smash against the floating barges. Deep-sea divers secure heavy oxidized chains to the sunken TBM shell. Blind. Freezing. 100-ton steel chunks violently ripped from the muddy depths. Back on land, the human element takes control. 25,000 workers, the lifeblood of the fortress. They do not stop. 24-hour cycles. Shift changes blur together. An endless industrial nightmare. The sensory overload is absolute. The screeching grind of angle grinders against thick steel. High-voltage power cables snake through freezing, knee-deep mud. 18,000 heavy safety boots stomping on corrugated steel grates. The harsh yellow glow of sodium floodlights piercing the dense freezing fog. You stand on the scaffolding, 60 meters up. The wind tries to rip you off the precarious platform. Your safety harness snaps violently tight. 12-hour shifts in driving sideways rain. Fingers numb, muscles burning.
I watched the specialized welding teams, 50 meters below me, suspended in head arcs blinding the naked eye.
3,000 degrees Celsius plasma fusing 100-millimeter thick steel plates. The physical toll is immense. Heavy respiratory gear filters out toxic concrete dust. Exoskeleton suits aid in lifting 50-kilogram rebar bundles. Precision must remain flawless. Fatigue is a lethal enemy. One dropped heavy wrench, 100 meters of free fall, lethal terminal velocity. Safety protocols are military law. 1,500 safety inspectors patrolling the vast labyrinth, scanning every harness, every locking hook. The human cost of a $50 billion gamble. Flesh and bone building the ultimate machine. The inner containment dome is prepped. The final barrier. The climax approaches. The steel containment liner. 47 meters wide, 34 meters high. A monolithic steel dome. Forged to trap a catastrophic nuclear meltdown. SGC 250 engages. Big Carl roars to life. 12 massive diesel engines throttle up. 800 tons of steel lift off the frozen ground. Suspended directly over the gaping reactor cavity. The ultimate drop. 100 meters down. Absolute millimeter precision required. Massive hydraulic wind dampeners fight the brutal coastal gales. 100 specialized engineers monitor localized GPS sensors. The dome descends. Slowly. Relentlessly. 10 millimeters per minute. The shadow consumes the concrete reactor core. Steel meets concrete. The massive locking pins slam violently into place. A deafening metallic boom echoes across the Bristol Channel. The nuclear fortress is sealed. Inside, the future activates. Uranium fuel rods load into the core. Water pressurized to 160 atmospheres prevents boiling. 300 degrees Celsius radioactive fluid transfers extreme heat. Colossal steam turbines spin at 1,500 revolutions per minute, generating raw electricity. 3.2 gigawatts of clean energy. Zero carbon emissions. 6 million homes powered simultaneously. 60 years of guaranteed operational lifespan. The collapsing national grid stabilizes instantly. The threat of rolling blackouts is permanently erased. The darkness is defeated. The United Kingdom secures its future. $50 billion crystallized in extreme engineering. A monument to human defiance, overcoming the vicious ocean, overcoming shattered Earth, defeating time. The ultimate nuclear fortress is complete. Hinkley Point C stands ready.
What impossible megaproject should we bring to life next? Tell me below. Subscribe now. Do not miss the next build.